I'm going to begin this video with a challenge problem from the last video, which is a really good preview into what we're going to be doing today. So we have a semicircular track where the ends are of equal vertical height y, and a ball or a block is placed at point Z and then released from rest. We want to know which of the following is true regarding the height to which our object will rise on the other side of the track. And notice we have options A, B, C, and D. So if we knew that the track was frictionless, then you could say C is the correct answer, but we're given no information about that. So option D is the correct choice. You might have picked C because the lesson that this problem came from involved conservation of energy, and for energy to be conserved, the block would have to rise back up to point Y. However, if there's friction, then the potential energy lost by the ball would have been the work done by friction, and we've briefly mentioned work a few times. Work is defined as the change in energy of a system, and it is also equal to the force acting, the distance over which that force is acting, times the cosine of the angle between the force and the distance in which the object is moving. So, for example, say we have a box being pulled at some angle x from the horizontal. This is our direction of motion, but there is friction on the floor. We want to know what is the work done by friction. Well, that is going to be the force of friction times the distance over which friction is acting, and we are not doing the cosine of x because friction is acting in this direction, the box is moving in this direction. The angle here, theta, equals 180 degrees. The cosine of 180 is -1. So we know that friction does negative work on the box. It is therefore taking away energy. And you could also set this equal to their coefficient of friction, which would be kinetic friction since the box is moving, times the weight of the box, times d, and that is all negative. Alright, so now let's do some practice problems, multiple choice questions with work. Here's our first problem. We've got a force F acting at an angle theta from the horizontal, pulling a heavy block of weight mg at a distance d along a level floor at a constant velocity. The coefficient of friction between the block and floor is mu. We want to know the work done by the frictional force. So take note of the constant velocity. This means that our force of friction, which acts in the x direction, equals the horizontal component of our force F, which is F cosine theta. And we know work equals force times distance. Recall our direction of motion positive, and you can infer that from our options A, B, C, and D. So our friction is negative, so our work equals our negative friction times distance, because that force of friction wants to take energy out of our block system. And we know our F equals F cosine theta, so we can set this equal to negative F cosine theta times our distance d, and that matches up with option A in this problem. In our second problem, we have a 5 kilogram ball attached to a 3 meter long string that is moving in a horizontal circle at a constant speed. We want to know the work done on the ball, and you can infer that is done by the string. The first thing I want to do for this particular problem is draw a quick picture. This is just part of our path here's our ball. Here's the string going towards the center of the circle. So we know work, if you were to write out the full equation, is our force times our distance times the cosine of the angle between the force and the displacement of the object. So we're analyzing our string, so that will have some force of tension, and I'll move some distance. Now the angle theta here is what you want to look at. So the angle between, let's just say this is our direction of motion, the angle between our tension and our direction of motion will be 90 degrees. And the cosine of 90 degrees is 0. So that means the work done on the ball is 0. And that would be because the force causing the motion is perpendicular to that direction of motion. So keep that perpendicular fact in mind. If a force is acting perpendicular to the direction of motion, it does 0 work. And another thing I should note is that joules is our unit of work. Here we're given a variety of graphs that represent the net force as a function of displacement for an object moving along a straight line. We want to know which graph represents the force that will give the greatest change in kinetic energy of the object. Alright, so here we're going to call this 0 potential energy, gravitational potential energy. Here you've got our object moving on a straight line, just say arbitrarily in that direction. So that means the only type of energy we have is kinetic energy. So therefore any work done, which equals force times displacement, and our force is acting in the direction of motion, 90 degrees, so cosine is 1, and that will equal our change in kinetic energy. So we want the largest possible product of force times displacement, which would be the largest area under these various curves. So clearly our smallest area will be C. It's not even one full square. Next we can look between A, B, and D, and if you notice, this here is a triangle. We know that area is 1/2 times base times height, so we can say area of A is 1/2 times a base of 2 times a height of 2, which just gives 2, and the area of B is base times height, and that's just 2. These two are equal, meaning neither of them is the right answer, and you can confirm that by looking at D, which has this entire square, and know that these graphs are all to the same scale, plus a majority of this square and this square. So D clearly has the largest area, therefore a force like that will give the greatest change in kinetic energy for that object, thus the greatest work done. Alright, here's the challenge problem for this video. The solution will be on my Instagram page shortly after the release of this video, link in the description, or you can find the video solution at the beginning of our next lesson, which will be free response questions on work and energy.